This is a word problem that's giving us the fact that we have this memory experiment happening and this rate of memorization. Remember, rate is telling us we're talking about a derivative here. So this is our rate of memorization. And using that rate, they want us to figure out how many words we can memorize in the first 10 minutes. What I always tell people is, kind of remind yourself that when you see these word problems, really the only time they start you with the derivative is kind of when they want you to undo that derivative, right? To take the antiderivative. So when you see something like this, you got to be leaning towards the fact that you're probably going to want to take an antiderivative. And if you think about it, an antiderivative is really good at is it's an accumulation tool. It can add up total amounts of something. And so here we're trying to find how many words we can memorize over a period of time. How many words can we accumulate over a period of time? And so that's really pointing us very much to the fact that we're going to be using our antiderivative, a definite integral, to do some accumulation right now. So we would set this thing up. We'd say, okay, I have the integral from, we've got our bounds here. So lower bound, we're talking minutes 0 to 10. You got to kind of stop at this point when you start getting into the units and make sure your units are matching up to be what you want them to be. So they're giving us minutes. That's 0 to 10 right there. But then our rate, our derivative piece is talking to us about words per minute. So what we know is our m prime of t is words per minute. And then what we're going to be multiplying that by is sort of our dx in this situation, our dt right now, is just going to be minutes. And so those units here need to match so that they can work with these units of our rate. So what I mean by that is if what they were giving was first 10 minutes right here, but then your rate is talking words per hour, those aren't going to work. If I have hours down here and minutes up there, that's not going to be what I need. So you would have to do a unit conversion on one of them. It doesn't matter which one, except, you just need to make sure you get your units matching up. You'd have to convert minutes, words per minute into words per hour, or convert 10 minutes into how many hours that would be. But you've got to get those units matching up. We know that our accumulation is going to work out because this right here is how we know what the total amount is. Whatever you're taking the antiderivative of, that equation right there, multiplied by your dt units is going to tell you that you just work it like a unit conversion problem. So what you're getting out of there after those minutes cancel is you're getting total words. And that's what we're looking for. We're looking for total words right here. So we would take the antiderivative of our derivative. Oops, and my dt got a little funky out of place. That's what happens sometimes when you're writing ahead. And that's it. We're set up. We know what we're looking for, and we just evaluate this antiderivative. This is a bunch of stuff being added and subtracted, so we're just going to apply our power rule right now for antiderivatives. The power rule says we're just going to add 1 to the power, and then step 2 of the process is we divide by the new power. So working our way through this, we would get negative 0.009, and then adding 1 to the power, we would get t to the third, divide by that new power of 3, plus we get 0.2, and then that's an unwritten 1 on that, so adding 1 to the power gets us t squared, and then divide by that new power. And because this is a definite integral, we get this evaluated at, and then from t equals 0 to t equals 10. Getting that final answer, you just apply what I refer to as the top minus bottom method. So we're going to take the top value, plug it into this equation, and then subtract off the bottom value plugged in. So we get negative 0.009, and then instead of t, we plug in the top value of 10, divide that by 3, plus 0.2 times, and then that's going to be plugging in 10 for t squared. There's our top value, and we subtract off of that the bottom value plugged in. So negative 0.009, instead of t, we now have 0 cubed over 3 plus 0.2, plugging in 0 for t squared over 2. And then pop that into your calculator, get out your answer, and what you're going to see is that when you plug that all in, all of that ends up equaling 7. And so this would be 7 words because that was what we were getting. 7 total words were memorized in the first 10 minutes. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.